Let's do a quick example of a t-test. Again, basically performing a significance test when we do not know the population standard deviation and we want to use the standard deviation of our sample instead. And let's keep working on the same example about the researcher in the Philippines who she's told that the average test score for GMAT students is 550, but she is thinking that her student population is lower than 550. And we did an example where she took one sample and we came up with a conclusion from a t-test. Let's try another though. So what if she obtains a sample mean from her students of 531 from 20 student scores and calculates their standard deviation to be about 95. And the question is this strong evidence to reject the null hypothesis? So it's the same exact example we did in class. Let's just focus on the math. So again, we could start off with the t-statistic. So the t-statistic here would be x bar minus the null hypothesis theoretical mean value divided by the standard deviation divided by the square root of the sample size. And then we could get our t-statistic value. So we would have 531 minus 550 divided by 95 divided by root 20. And this would give us a t-test statistic of approximately negative 0.8944. And again, we need to make sure to look this up in our table T to figure out if it's strong evidence to reject the null. So again, we have our t-statistic. Now we need our p-value. That's always what we need from there. An approximated value of our p. Here, remember, we need to know the degree of freedom. So degree of freedom would be 19. So we want to go to row 19 on our table. And we had a t-value of about 0.894. So 0.894, remember how we do this one is we don't know exact values of p, but we can have an estimated range because our t-values are all along this row here. And we just look for, well, where is our number between? Our t-value that we obtain, 0.894, is between 0.86 and 1.01. And so looking at, since this was a one-sided test, this would place us somewhere between a p-value of 0.20 and 0.15. So p-value, we don't know exactly just from looking at a table, but we know a range. So we could say that p-value is between 0.15 and 0.2. And we could use a calculator to figure it out more precisely, but remembering the idea of strength of significance, generally it's always got to be less than 0.1 in order to be strong enough evidence, right? Because it's all dependent on alpha. Here we're not told alpha, and if you weren't told alpha, you just want to try to make a conclusion based on common sense. And here 0.15 and 0.2 are not good, right? It needs to be at least lower than 0.1, and generally 0.05, 0.01 are stronger and stronger significance, but this is not strong evidence. No, not strong. And another thing to kind of keep in mind is the test statistic, whether it's Z or T, the larger it is, the better, the more significant our results would be. Really, really small numbers that are less than 1 are typically not statistically significant. Again, it's not a generality. You want to go make sure to calculate the probability in every case, but 15 and 20% is not good because that random chance can surely dictate that. And again, it's not, it's a delineation of strength, a measurement of strength. And anything above 10% is not strong. Or if this bothers you, again, we could do this more accurately by running a t-test on the calculator and putting in all our parameters. So here we had a sample mean of 531, a sample standard deviation of 95, and a sample size of 20. And we could run through the calculation on here to figure it out more precisely. And with the calculator, we're getting a p-value more like 0.19, which is in between our thing. But again, at the end of the day, not significant because it is not less than 0.1.